Hello everyone and welcome to another episode of Solving Advent of Code in Rust and try to learn Rust in between. I'm Roberto and we have
Luciano.
Cool. Thank you everybody for following along. If you never did Advent of Code, Advent of Code is a challenge that is published every year in the Christmas period. We are working toward last year's one. There are 24 challenges and you can find them on adventofcode.com. We are publishing all our code here.
1 second.
Yeah, here. Let's see if it works again.
Is it working?
Okay.
Yeah.
And we have a YouTube channel where we are publishing all the recording. You can find the link in the description of the Twitch channel. Last time we were doing exercise 18, part 1. We are 70% in the Rust code of it. We shown the Python code for part 1 that was working. What's left to do at this point is we have to sum together snailfish. The challenge was about snailfish numbers, this kind of strange concept. We have to implement sum them together and sum all the rows that we have in our input. When we are done with this, we will jump on part 2 in Python. We will show how to solve part 2 in Python, and then we will try to implement part 2 also in Rust.
Perfect. So let me share my screen and we'll do a super quick review of what we did last time. So it should be clear what's remaining to finish part 1 in Rust. Okay, you should be able to see my screen. Let me know if it's too small.
Yeah. But for this fine.
I like it to keep it with a little bit more space so we can visualize the code a little bit better. So let's see the input really quick. And I think that's a good way of summarizing what we want to do. So basically we have a bunch of expressions in this particular snailfish math where numbers are represented like tuples and they kind of grow in a nested way. You might have a tuple where one of the items is another tuple and you can create recursive structures that way. And there are rules around how do you sum this sequence of numbers to another similar sequence of numbers. And if I remember correctly, the exercise was asking us to implement the sum of this one with the next line, then take the result and sum to the next line and continue until the very end of the input. So we have 100 expressions that we need to kind of reduce together. And then for a given expression, there is a function called magnitude that allows us to kind of evaluate the one expression to a single integer. And that's our solution for part 1. So we should implement this sum where we reduce all the numbers together, and then we calculate the magnitude of the result, and with that we should get our solution. Did I remember
for part
correctly?
1? Yeah. If you go in our test that we implemented the last time, we already did something. And going through the test, we can see what we did last time.
So let's start from the beginning of the test. So these are the tests for the 2 solutions. Okay, so the first thing that we did is parsing this expression. So we have something like this, and we need to represent it in a structure that makes sense in Rust. So what we are doing is we are creating a vector of snum. So we created this struct called snum that represents a snail number. Let's call it this way, snailfish number, which is one of these expressions that we were seeing, one per every line. And in order to parse this, because it's a kind of a recursive structure, what we are doing is actually not making it recursive, but make sure that we have a vector that it keeps the order. And then for every entry, you can see here, every entry has a number and this vec. The number itself represents a particular position of a number.
The number is the number.
Sorry, you're right. Let me explain this again. So we are trying to represent this in a way like a tree, but rather than representing the tree as a nested structure, we are representing it in a flat way, where for every node, we keep the node value, which is the first number, and then the second value is kind of a path in the tree to actually get to that node. And this is kind of a binary tree, so you can imagine that the 2 options you have are left or right, and you keep descending. For instance, this one means number 1, you can find it if you go left twice. Number 2, you can find it if you go first left and then right. And you can see that here we have 2 levels of nesting. So the first number is left, and it's 1. Then we have left, right, and it's 2. And similarly with 3, you are just going 1 time right. And here we have a more complicated example, but the idea is the same. So we are trying to parse this expression and make sure it matches. Then we have this idea of magnitude, which, if I remember correctly, it was like multiplying all the numbers on the left by 2 and all the ones on the right by 3. And then
left by 3 and right by 2, but okay, you're right.
So this was another reduce operation. We can check the code, but it's not particularly interesting, to be honest. Here we have tests for that as well. And now here we add on, this was the reduce.
Yeah, this is the because there are rules in those numbers. Those numbers, if they have more than 5 levels of nesting, or if a number is bigger than 10, you apply rules. If something has 5 levels of depth, his left number goes on the left, his right number goes on the right, and is replaced by a 0. If it is bigger than 10, it got split in half, and if it's odd, the left half is smaller than the right half, and then you create a new node that goes one level deeper. After you apply all of these rules, because when you split a number, you can jump to depth 5, and when you are at depth 5 and you sum numbers, you go back to depth 4, but the number that you get can need to be split again. So you have to do all of this until there is no more work to do in reducing these expressions. And this is the reason why we have also a true and false that tell us, if you see in the very right of the test cases, there is true or false that tell us if there is more work to do or if you are done with the work.
And we can see when you call reduce, you get a Boolean back, which needs work. So we implemented reduce to tell us.
And we modify expr in place.
Yeah, that's why it's a reference, a mutable reference.
A mutable reference, yes.
Okay.
Now we have to implement a function that is taking 2 snail numbers, put one on the left, put one on the right, and then pass them through a round of reduce.
Exactly. So reduce, by the way, was doing the 2 operations that are explode and split all in one, and you can check the code here. It's also in the repository in APR. But again, if you have questions, ask in the chat and we'll try to answer. Okay, so now what we want to do is to implement a function that is called sum, where we get snum.
We got a vector of snum on the side and another vector of snum on the other side.
Is it one snum or is it a vector? Given that we implemented the type snum.
The type snum is the single number inside the vector. So it's a vector of those. Our snailfish number is a vector.
Oh, yeah, you're right.
For example,
right,
magnitude.
Right.
Yeah, if you look at magnitude, for example, it's taking a parameter. What is the magnitude function? Probably you have to scroll.
Yeah, we could have created something like this, type snum exp, which is basically an expression of its number, and we can say it's a vec of snum.
We can do this later with this refactor later, when the tests are green.
So basically, this is every time we have that, we could technically replace.
Okay, if it's that easy.
Yeah, it's like when you do type, it's like an alias. So we have expression 1 and expression 2. And what this returns is another expression, right?
Yeah. But expression 2 is lacking an R.
Oh, good catch. Okay. So what were the rules? I don't remember around.
Okay, you have 2 numbers. One goes on the right and one goes on the left. And then everything got raised on one level. So to do that, we have to take the expression 1, taking all the position and prepend to them a left, an L for left, taking expression 2, prepend to all the position a R, and then stack the 2 vectors together.
That makes a lot of sense. So it's like if we have 2 trees that are independent, we are creating a new node at the top.
Yeah.
And then the first tree goes on the left branch and the second tree goes on the right branch. So of course we are adding one level of nesting, one level of depth in the tree, but also we need to update all our positions because we are storing the numbers.
And we have to prepend, not append, because the position is before all the others.
Okay, so this one is basically result, we can say that is of type snum expression, and we can initialize with an empty vec. So this is where we're going to append things in the end, and this is what we are going to return, right? Yeah. Well, we can just say result. Cool. Then what we want to do is to take all the items from the first one and start to push them into the second one. But for every item, we are going to remap it so that we can update the coordinates.
For example, in Python, there is an extend. So given a vector, you can extend the vector with another vector. I don't know if in Rust there is something similar.
I was thinking something simpler for num in expression 1. And basically what we do is
result.push.
We need to update. So we need to do num, let mut new num. And this is going to be a num.clone.
Yeah.
And then basically we do new num dot position dot, can you do prepend?
Yeah, we have to insert in 0 position.
Okay, 0, and we do the element, which is going to be an L, because these are on the left side.
Yeah, we need to specify post colonel or
Post.
L is an,
you're right. I think
because L is an enumeration.
And post uppercase.
Okay.
Yeah, and now we can do
now we can
result
append it
dot
to
push
result.
of.
I think all of this can be done with a map, but let's be fancy another day.
We could have done a chain of iterators and then a map, but then I don't know exactly how do you say for half of the chain use an L,
Yeah.
and half of the chain use an
Half
R.
of the chain use an R. Yeah.
So I'm gonna be a bit explicit here, even if it's a bit of copy paste. So left 3, and then right
3 because it's a very long tree.
Okay, so this one is expression 2.
Yeah, and this goes on the right.
On the right, and then we still keep pushing in the result.
Yeah, and now we have to apply reduce until there is work to do.
So here what we can do is while
let mutable. Yeah.
Let. Can we do a while let? I think we can.
A while let? What kind of sorcery is this?
Let's see if this works. So while let needs.
Well, can't we just do while reduce expression is not enough? Can't we just? We don't need the needs work. We can just do while reduce.
Okay. Oh yeah, you're right. You're right. Because this one, okay, yeah, definitely.
And do nothing.
And do nothing. Yeah. Now, why does it like reduce?
Because it must be mutable.
We need to explicitly say this. We need to pass it as a mutable reference. So that should be it, right? Can we write a test?
Can we write a test?
We might have some in the README, right?
Let me think. In the README, there is something with everything, with a small number of lines. I was looking if I have something handy. Just give me a sec. Well, I can write a piece of code in Python that provides me what we need. Just give me 10 seconds. Okay, but it's providing me the parsed version of this guy. That is still better than nothing, but it's not very useful. Let me go with a simpler expression.
I mean, we can probably take.
No, because then there is a reduction.
Okay, let's see. Some expression 1 and expression 2 equal expected. So this is our test, but of course we'll need to put values there. Let me see what the README was doing. So this one is a good example, right?
Oh yeah, you're right.
We can just copy paste this one and see if it gives us the expected
He's also
result.
doing the reduction. There is a reduction there or not? Let me see.
I think so. Yeah, I think so, because that's showing all the steps from the README basically.
Yeah, there is a reduction. Yes. Yeah, cool. Let's use that.
So if we use this and this, let's see if we have been doing the right thing. Okay, people in the chat, you're being very quiet, so at least make a bet if this is gonna work.
Make a bet, yeah. You're winning nothing.
Okay, it did work.
Yay.
And when it works straight away, I'm always skeptical. So I'm gonna change
in this exercise, everything worked straight alone at first try. I'm what you did. You changed something.
I broke something intentionally, and it is indeed failing. I only changed the last one. Well, the last number was at 0, and I put a 1. So I'm confident this is gonna work. We might add a few additional test cases if we want.
If they are in the README, you don't mind.
We can easily
copy and pasting.
So let's do let cases, and a case is basically a vec.
Yeah, we do our fixture array.
And a vec has 3 values, which are the
left, right, and expected.
Exactly. So we have 1, 2, and 3. Okay, and we could keep going and add more, but let's see if this works. So what we do is for, and we want to use left
x_1
or x_1 just to be accurate, yeah. x_2 and expected. In cases, and we basically want to do this.
We have to parse.
We have to parse. You're right. So we want to do all of
Sum
this.
of parse x_1. Can't you just
Yeah.
do that just in line? Plus
We're
of parse x_2. It must be equal to the parse of expected.
Point, and we can remove all of this.
Yeah. In theory, this is the same as before.
This is the same, still working. So let's copy a few more examples from the README. Let's copy other 3 of them.
Yeah, they are enough 3.
Oh, I like the coloring. Okay, so another case is we have 3 of them, right?
Yeah.
Can we do something smart with
multicursor?
Let's see. So what do we want to do? We go to the end. Actually, we go.
You have to put an open, closed, and a comma. Done.
And we can remove the latest comma.
Is Rust opinionated on top of that? For example, in Go, you have to leave. I see that the formatter re-put the comma in place. So yes.
Apparently, it's opinionated, but I think it's only the formatter, not the language itself.
No, not even in Go is the language itself, or probably it is. No, probably it is the language itself. But in any case, if the formatter say that the way is that one, I'm not arguing. The way is that one.
Yeah, it's easier not to argue when the compiler itself is opinionated.
Yeah, no. I always thought that all the discussion about code style were just wasted time.
I tend to agree, except semicolons in JavaScript. Okay, let's go.
Okay. You almost agree.
Works. Awesome.
Okay.
So now we can start to implement part 1, right?
Part 1 is a fold with that function that we just wrote of all the input lines.
So we take input.lines. Input.lines. Then we do map
to with parse. So now we have expression, and now we do a fold. The starting value is the first line. Okay.
Right.
Because the start value is the parse of the first line, so it's the first line of after the map, and then we have to fold with all the other ones. How you do that in Rust?
Yeah, with fold you have to explicitly pass the initial value.
So there is something that you can not pass the explicit value and assume that the first element of the sequence is the initial value.
Is that window thing that was?
You sure?
Was it a window thing?
No, because we just need for the first run the first value, or you take the assign the iterator to something.
Lines, expressions.
Yeah.
Right.
Assign.
And this is should we collect? Actually, no, we don't need to collect.
No,
we can just do let first expr, and we can do expressions.next.unwrap because we know there is one. Now we can do expressions.fold.
Yeah.
Because this is going to continue with the iterator.
Yeah.
Skipping the first one.
The init value is the first expression.
So here we have current and accumulator. And what we want to do, the init value is first expression.
It's not the other way around.
Is it? In JavaScript it's this way, but I don't know yet.
It's not the other way around in
Fold. Come on, give me the docs. Self init, you're right. And to be fair, it makes more sense. I never understood why JavaScript does it the other way around.
Because the accumulator in JavaScript is optional. So to have option in JavaScript, in vanilla JavaScript, to have optional arguments, you have to put them on the right.
Okay, so this one.
And now you have to retard the magnitude of all of this. Okay, here we have to pass as a function. We have to use our sum. We call it sum.
Let's call it let sum. Yeah, and this one is basically sum of accumulator, which is
ACC.
And current. And this is going to give us the final sum, and finally we can return magnitude of sum.
He's complaining about sum because he's shadowing the outside one, or
which one? Oh,
the function.
Why? Consider borrowing. Because magnitude, magnitude needs, yeah. Is it?
Magnitude needs a mutable. Why?
No, it doesn't. Yeah, what's the problem then?
Probably we just it just needs a reference.
Expected a U size found a U32. That's why. Why it's expected a U size?
No,
You can return a U32, I think.
Yeah.
And also, the test shouldn't matter. Okay, now sum-wise complaining, considering borrowing. Okay, because we are not mutating, we just want a reference. We are not taking ownership of in the magnitude.
No.
So is this going to work? Let's see. It doesn't. Now good luck debugging it. Let's see if we can figure it out. Ooh, totally different number.
Nice.
Interesting. Are we missing any step or repeating any step twice? How do we figure that out?
So we are taking all the lines and we are parsing them. Cool. Then we take out the first one.
Exactly.
And we sum the accumulator with the current one.
Actually, let me check something as well. When we call fold, what is the order of the two arguments, current and accumulator?
This is important because one goes on the left and one goes on the right. Try to switch them, just by curiosity. Switch them in the function declaration in line 145.
You mean here, not here, only
yeah.
Yeah,
there. That is the same in the end, but
okay. Why is complaining? Oh, because probably we could just say sum here as a remove all of this and just leave sum.
Try.
Okay, first of all, let me rename this because this is confusing.
Yeah,
let's call it resulting sum. And here, I think we can just say sum.
Okay, let's see.
Yep.
Okay.
So we inverted accumulator and the current value,
Yeah.
which is a classic issue with fold
or
reduce. Awesome. Do you want to share part 2?
Yeah, I think I'm sharing the screen. You just have to show it.
Yeah,
right?
Let me switch your screen.
Tell me when I'm live.
You should be live now.
Okay. If you remember, part 1 is implemented in a very similar way to what we did in Rust. There is parse, reduce, sum, magnitude, a bunch of tests. And part 1 is just the magnitude of the sums of all the inputs. Cool. Part 2. Do you want to read part 2 before, or do you
Actually,
want to show
maybe we should. Let's quickly read part 2 before we show the solution.
Let's change the screen.
Let's reswitch. Yeah.
Reswitch.
Sorry about that. Okay, so part 2. So we did all this assignment for the snail fishes, I think they're called, and we got them a solution. But then, of course, we realized that there is more to do. You notice a second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? So there is like a second exercise to do on the back of the same input. Note that snailfish addition is not commutative. So if you take x plus y and y plus x, they will potentially produce different results.
And we just tested it by switching the fold parameters.
Exactly. Again, considering the last example homework assignment above, the largest magnitude of the sum of any 2 snailfish number in this list is this one. What is the largest magnitude of any sum of 2 different snailfish number in the homework assignment? Can I just propose an idea and then you tell me if this is how you implemented it?
Yeah, probably it is.
Okay, very brute force style. You do a nested for loop where you compare all the lines with every other line. And then for every one of them, you try the 2 x plus y and y plus x. And while you go through all of this combination, which is going to be n squared multiplied 2, you keep a record of what is the biggest value found so far. And at the end, you return that value, right?
Yes, I'm doing that.
Perfect. Okay, so nothing crazy there. I don't know if there is any smarter way, to be honest, because
probably, but this is with our input. This is fast enough.
Yeah, but at the same time, with this weird math,
predicting an outcome of a sum is not that easy, and then predicting the magnitude of that sum is even less easy. So,
but it should be manageable because we have 100 expressions. So how big is it going to get? N squared is 1 million operation multiplied by 2 million.
10,000.
Is it 4 zeros? So 10,000. Yeah, you're right. So it's okay. It's very manageable.
Yeah.
Cool. Right. Let me switch again. Sorry for my rant.
I like runs.
All right. Off you go.
So, like you said, for all the line in the input, for all the lines in the input, if it's not the same line, so if I am on the same line, I'm not summing the line with itself. I sum the two lines and I reduce them, and then I yield the magnitude. And here, outside of the part2 function, that is a generator at this point, that is giving me all the magnitude of all the possible combinations of the lines, I just take the max.
I like this solution.
This runs in, all the other one runs in 0. This runs in 1. So you see that is almost 2 seconds. So you can see that it's quite heavy compared to the other ones. But also remember that here we are running on free machines on the internet, so they are not that big. So yeah, nothing fancy. It's just 2 nested for loops with the sum in the middle and the yield of the magnitude. I could have done the same without a generator, keeping a ret 0 here, doing the ret is the max between max and the new value, and then retarding max at the end of the retarding ret at the end of the loop.
Or you could have done like an if statement. If this is bigger than the previous one, and the previous one starts at 0 or whatever, minus infinite, I don't know, then you reassign it.
Yeah.
Okay. It's interesting because in Rust, we don't have yield yet. We don't have like an easy way to create generators. We could create an iterator ourselves, but it would be a pain to keep track of the state. We probably need to keep track of I and J and figure out how to increment them every time somebody calls next. So I think we're going to do a simple solution. Then if we have extra time, maybe we can check. I think there is a crate that gives us a macro where you can implement yield. So maybe there could be some interesting experiment we could do if we have extra time today.
Okay, let's try to implement this then.
Cool. So back to my screen. Let's go back to the code. Okay, so what we want to do, I think we can write the solution directly here because we have already all the utility functions, right? What we need to do is we want to collect all the lines. I think we can collect them straight away into one big vector because we'll need to reference them multiple times. So we can
we can collect in a vector already parsed.
So this is going to be pretty much similar to the previous one. Input, I need to remove the underscore, dot lines, dot map to parse, and then dot collect. And now we should have, doesn't have to be mutable, I think.
Do we need to tell the type somewhere?
Yes, you're right, because collect doesn't really know to what.
Yeah, if we want a vector, a map,
yeah, this needs to be a vec of expressions. So we say that this is what do we call snum expression. Okay, so now it's happy. Okay, now if we want to do for, let's do the same thing that you did for I in
0.len of expression.
Yeah, expression
len. Okay.
.len, and then we can do for j in 0.expressions.len, and now we can also do let mute max equal 0. And basically what we want to do is
we have to check if we are not on the same expression. So if we are in the same number.
Okay, if I, we don't need a parenthesis, I different from j, good point. What we want to do is let val equal magnitude of sum between expressions get I dot unwrap and expressions dot get j. Actually, let's do something because we need to use it twice. Let express
why twice?
Because we need to try flipped, right? Or no?
You already tried flipped because the 4 is starting always from 0.
Oh, right, so right. You are checking.
If I is the left one and j is the right one, we are always putting one on the left and one on the right at one point.
So if you check 0 against 1, eventually we'll also check 1 against 0. Okay, you're right.
Yeah, at one point, yes, because j is not starting like in a lot of cases from I plus 1. J is starting from 0.
Very good point. So now, if I didn't mess up parentheses, which I probably did.
Probably you need references because magnitude want a reference and sum is returning not a reference but an object. Right?
Okay, so can we just put a reference here and is it gonna work?
And expression the same. You want a reference. He doesn't want a.
Let's see if this is going to make it happy. Probably not, because probably we'll need to assign it, because otherwise probably value doesn't live long enough or something like that. Try using a conversion method. What?
Expected. Ah no, sorry. He put a star, not a.
Here, what does an expression? Oh yeah, this is a typo. Let's see what's the problem here. Cannot move out of shared reference. Okay, we'll definitely need to assign.
Okay.
Or I don't know if there is any other way. Let me know in the chat. Hey, hello, Loudmo. Would it be possible to write this as an iterator instead of a loop? So what we want to try is actually to write it as a loop first, because it's easier for us. Then we would like to do it. We could try different things. We would like to do a generator, because in Python and in JavaScript, there will be an easy way of doing it, and that's our background. But I know that the Rust generators are not stable yet. There is probably a crate that allows you to do yield. So we could try to do it this way first, and then if we have time, either try directly the yield crate, or whatever it's called, I don't remember, or try the iterator first, which is going to be a bit messy because we need to manage all the state, and then if that works, we'll try the iterator. Let's see. If you have any suggestion, let us know. So that's the first one. Then we have expression 2, which is get j. Okay, now at this point, val is the sum, the magnitude of the sum of x_1 and x_2.
Why you put a reference in front of x_1 and x_2? They are not already references.
Oh, you're right. They are already references because we are getting them straight away from the expressions.
And the sum is taking references, or?
Now, why it still doesn't like it?
Because sum is not taking references. That could.
Right, so we need to destructure here, and I don't think it's going to be happy with it.
Go in sum. Go and change the sum signature, because we don't need to destroy. Sorry, my Google Nest. We don't need to take
That's
ownership of them.
That's a very good point. And I wonder if this is going to break something. So it doesn't change anything here, because as you said, we are not destroying anything. Here, the sum now will need to do a map for part 1.
Yeah. Well, we can just accept parameters. No.
I think we just need to say, what was the order? It was accumulator first.
And then current second.
Current. And what we want to return is the sum of which one went first? The accumulator and the current, but now we need to pass ampersand. So we need to pass references.
But they are not already references?
Are they? In this case, part 1, no.
Try to remove the ampersand, sorry.
Let's see. Fold gives us what? I think, let's see. Try to remove the ampersand. Nope, fold complains. Why does it complain? Give me the error.
And pass a reference, pass first expr as a reference instead of as a value.
Closure expected 2 distinct arguments. Oh, I didn't. Wait. Closure.
You put a tuple. Remove the round brackets.
Good point.
Now
we need
Okay, yeah, now we need it.
A reference. Okay, so part 1 now should work.
Run the test for part 1. Run the test for part 1.
Yeah, I was just making sure that we didn't have anything else broken, which we might have. Yeah.
Okay, no, it's not going to work.
So where is it, this one? 289.
Our tests are failing.
Somewhere else we have a broken test. Our sum test, yeah. So should this one do like this? Is it going to work? Cool. Yeah, works. There are warnings because we have values.
Yeah, we have open code. So.
Part 1 still works. Cool. Okay, so back here. So this one is the new value, and at this point we can do if val is bigger than max, then max equal val.
And we can return max in line 167. In theory, part 2 is done.
So that should be the solution for part 2.
Yeah.
Let's see if that's the case. It is a bit slow, 0.7 seconds, but
in Python was 2 seconds, so yeah.
Cool. As far as I can tell, you will necessarily have to copy clone the elements over which you're looping. So we didn't have to do that because
we accepted references in our functions.
Yeah, basically the problem was this sum function that we did write in a way initially that was taking ownership of the two values, but that was not really needed. So we actually updated the signature to accept references. Yeah, exactly.
Something that I have to remember in Rust is that think if your function really need to take ownership of what it's doing. And a lot of stuff, it doesn't need to take ownership of the parameters. It just needs the parameters, but doesn't need to take ownership of them. And it's an error. I forget to do that often.
Yeah, I actually like that often that will emerge when you start to use your own library, your own functions, that will emerge very quickly. So I like that Rust pushes you eventually to do the right thing.
Yeah.
So depending on the Rust, let me show this one on screen. Depending on the snum type, it might not be copyable. I forgot this advent of code. Yeah, we didn't really make it copyable because it's not like a base number. We gave it a little bit of structure and it could be quite big.
But well, it's clonable. We made it clonable.
But not copy. So
not copy.
When it's clonable, you need to explicitly .clone. When it's copy, every time you use it, it will basically make a copy on its own. Because like generally you would implement copy only for like very small numbers where the size of the pointer is pretty much the same size of the data you're trying to store. So yeah, this one could be potentially very big if we have a big tree. Well, relatively big.
Relatively big because when it's level when it is 5 levels, we always explode it. So it can't grow more than 5 levels. But in any case, we went with references just to be cleaner.
Okay, so what I'm gonna do, I'm gonna commit this solution, and then we can try...
because it's working. Put a commit so we can revert to it if we mess up.
So then we can search what was the name of that crate, or do we want
to try the generator crate or the iterator approach? The generator crate?
I am more curious about the generator, but we might have time to try the iterator approach as well.
Let's try the
so we can actually show the difference between the two. Because I'm already making the assumption that writing the iterator is a bit painful because we need to keep track of I and j as a state for the iterator.
Yeah, it's not impossible. It's similar to the one that we did the episode 17, you remember? That was incrementing a variable. When that was overflowing, was incrementing the other one and going back to with the first one.
Yeah, we have an interesting suggestion here that with the iterator approach, we will likely want the itertools crate, which we have used once, but I think we used some very simple function. So I'm not really sure where you're going with this suggestion. If you have some specific functionality you would like us to explore, that could be a good suggestion. We are okay with importing additional crates and try different things.
Also, another interesting comment from WGAFA is that vec in that snum type prevents it to be copyable.
Oh, that's a good one. Yes. So even if we wanted to make it copyable, which I think it would be a bad practice, it wouldn't be doable.
No, because like you say, it must be memcopyable. That means that it must be a fixed amount of memory of no size that can be copied. The vector is not a fixed no size. We could have done the vector of enumerate with 5 bits in the end. So it could become a fixed amount of memory. But working with bitmask is always tricky, so we avoided that. And we stayed a little bit higher level with the concepts.
Yeah, that could be another thing we could improve if we create a type that allows us to manage the bitmask and then use the type. That could be another option for us to improve something.
Yes, I have no idea how to do that. I would do an integer and then go with power of 2.
No, we could wrap the integer type in our own type, but that our own type doesn't add additional data, just add methods to check, like what is the path, to change the path and stuff like that.
Oh no, it's not 5 bits enough because you need to keep track also of the depth. That can be maximum of 5, so you need another 3 bit. Oh, you can stay in you can stay in 5 plus 3, so you can stay in 1 byte. Yeah.
Okay.
Fine.
We have another suggestion which I think is good. I cannot highlight this for some reason. I think it doesn't like the Unicode arrow there. Anyway, I think the suggestion is saying that max is equal to val.max and max rather than this if statement, and that should be the same. Let's see if the test is up. It makes sense to me. Yeah, that works. Cool. So basically we are... Oh, you were able to highlight this, Roberto?
Yeah.
I don't know why it doesn't work for me.
I'm using Windows, so it's better.
I mean, it's running in the browser. Shouldn't make any difference.
You never know.
Okay, cool. So iterator or generator? Should we try the iterator first?
Okay, that's right.
Okay, so where do we do this? Let's do it here for now, and then we'll change it. So struct, what do we call it? Exp combinator or something like that?
Yeah, exp combinator is fine.
So what are the things that will be in the state?
The state is y and j.
So y is a u sides, j is a u sides. That's it, right?
They both start at 0, but okay.
Okay, cool. And now we also need a reference to the list of...
because we keep a reference, okay.
Right? I will do it with a reference. So we want to have expressions.
So we will return 2 expressions.
Which is reference to vec of snum expressions. Yeah, and we will return the couple of them.
Or the magnitude of the couple of them together.
We could also, I guess, if we change the name, right?
Yeah.
I'm thinking the expression combinator is just giving you the couple, and then you can do whatever you want with them.
Okay.
So that's why I...
Okay, but fine for me.
Oh, okay. Here we are getting a suggestion, which is, I think you want itertools combinators. I never use this one. Let's check it out.
Combinations. Those are permutations, because we also, if we have A and B, we want A and B and B and A. Because
let's see what the thing is giving us. Rust, not Python. Is it combination? Is it this one? An iterate n length combinations in an iterator. C combination.
Try to look if there is a permutation. Probably it is, because
But I have no idea. Doesn't seem that it's called permutations.
How can it be called?
Okay, let's try to do it ourselves, and if somebody in the chat knows how to do that in an easier way with itertools, we'll switch.
No, because combination, typically, if you have A, B, and C, it will give you A, B, A, C, B, C, and nothing else. But we need A, B, A, C, B, C, C, B, C, A, and B, A. So we need also the other way around. That's from the combination point of view. The order of the elements are not important. But in this exercise, the order of the two are important, as we see before. As we saw before.
So this one returns a new expression combinator where I is 0, j is 0, and expressions is expressions. And then we can implement the iterator trait, right? So implement iterator for, we need to do the thingy because we are using a reference for exp combinator A. And now the type item is a tuple of
reference
A of snum expression.
Snum express, yeah.
And another
snum express.
Right? And now we can implement the function. Itertools does have permutations. Sorry, let me show this on screen. Itertools does have permutations. I don't know why it didn't come up when you search. Did you make sure you were on the latest docs version? Probably not. That's a good question. How do you know?
Google it. Google is faster than the find in the browser.
Yeah, I was not in the latest version for sure.
Perfect.
So if we search permutations, it does have it. And what does it do? If you go from 5 to 8, it gives you 5, 6, 5, 7, 6, 5. So it gives you 5, 6, and 6, 5. Perfect.
Yeah, exactly. That is exactly what we want. Our vector dot permutation 2. Done.
So, okay, do we just want to use itertools at this point? Because at that point, you just get an iterator.
Let's implement our own, have a benchmark.
And then we use itertools.
Use this one and have a benchmark.
Cool. Sounds like a good idea. But thank you for the suggestion, Laumo.
Yeah, thank you. Back to us. What is the next function? Do we need to write it?
There is a big go to latest version in docs.
Yeah, by UI,
I am blind.
Strange for us. Yeah.
Okay, so here we need to implement.
What is the command line to go to the last version? What is the command?
X that takes a mut self and returns item, right? No, returns some result. Well, no, option item.
Returns item. In optional, yeah. Because we could be done. Yes, true.
Is it item or self item? I think it's self item. And then this is to do. That's my. Oh, this is a mute self, yeah. Because we can probably, and we'll probably need to mutate itself. Okay,
Cool.
we have other comments, but so if you look at the trait bounds for permutation, it requires clone, so it might not be the optimal. Okay, then it could be interesting to benchmark the two solutions. Okay, so what can we do next?
Okay,
we need to increase I every time or J every time, and then when we get to the end,
let's say that we increment J I every time. When I overflow the length of expression, we increment J. If J overflow the length of expression, we are done. So we remember from exercise 17 that the first stuff that we have to try is to check if J is above the length or the length. So if J is equal to the length of expression, we return known because we are done.
J is equal to the
expression's length, self-expression length, or we can just do
self.expressions.length.
Return known.
Return none. That means, okay, yeah, fair enough. None doesn't mean. Good.
Done. Now, we have to do what? Let me think.
What's the first item? It's going to be 0, 1, right?
The first item, we can start with 1, 0 is the same, right?
Yes. As long as we don't miss 0, 1, of course.
But with 0, 1, we'll go in the next time. So increment I.
So self.I equal plus equal 1.
Check if I is overboard.
If I bigger or not equal than self.expressions.length, then what do we do?
I goes back to 0 and J got incremented. Also line 188, you need the self J.
Oh, you're right. Okay, we here self I.
Yes, self everywhere.
Okay, at this point we can get.
I'm thinking a moment. Give me a second. How we can do this? Okay. I'm thinking, Luciano. Give me a second.
While I'm gonna do this, which I think we'll need to do anyway.
Yeah, I'm just thinking where. Yeah, go on and write that.
Oh yeah, this is self J and self I and self J. Now why doesn't
they are
this
J,
is some?
Why they are J in both places?
Because I did a mistake, so I and J.
Okay.
To catch.
I think this is slightly more complicated for the indexes. So let's move the two lines 199 and 200, the two with left and right. Move them before 192.
Before 192, so here.
Yes.
Okay.
Before those two lines, do if self I equals self J, because we don't want to do.
The
same element. Yeah, self I equals self J.
We'll need to skip a loop, basically.
Yes, but we basically need to increment. Let's say that we increment.
So which one is our inner loop? Is J, right? So we should always increment J first. Are we doing that?
The inner loop is I. The outer loop is J. In this moment, we switch them, but it's not important.
Okay.
We can cheat a little bit here. And what can we do? It's not important if we give out the same left and right twice, because their sum will be the same, right?
If we give the same left and right twice, it's just that I don't know if we get a value that is not supposed to be there, and maybe if that value is the maximum, the test will fail.
No, because we will always give back. Here we don't have to give out.
Are you saying to remove this?
Do you know what? When they are equal, a response with two empty left and right. So here.
But then our sum, no, we need a reference, so they cannot be empty.
Sorry.
Oh, you mean we create two artificial
Yeah. left and right, how you created them, are in the else of this if.
I don't think we can do that because we want to return 2 references. And if we return values created here, they're not going to live long enough because they get destroyed at the end of this function.
Okay. Then, if they are the same,
there is another suggestion. Why don't we return none if they are equal? I think that will stop the iteration, which is not what we want.
Yeah,
right?
we have to go on with the iteration, but not in this specific case.
We just want to skip.
We have to do a continue basically of this loop. But how you do a continue when you are in an iterator?
Yeah, that's for instance why I yield would have been easier because you just
do a continue in the loop and you yield. Exactly. Okay, we can't create stuff here. So copy.
But what if we just copy this inside?
If they are the same.
Sorry, we just copy this. I mean, if we are the same, we just need to keep incrementing j, right?
No, if they are the same, for example, we start at 0, 0 and they are the same in 0, 0. At the point we have to increment I. Copy from 199 to 204.
From 199 to 204, all of this, inside here, basically.
Yeah. So we go to the next element. Now we just have to guard that j is not overflow. So we do the same check. We move the check in 198 after this if. The if in the line 198.
The if in line 188
after this if.
Okay.
So if j is overflow, we return on and we are done.
Correct. Okay.
Okay.
Is everything else correct?
Okay. Let's try to use this. Sorry if I took some time to think about it, but like you said, implement an iterator is tricky.
Yeah. And to be honest, we've been very explicit here. Here we could have had another generic, so it could be easier to write the test. Right?
What do you mean by that? A vector of something?
If we do t, like we're never really using. We are never really using anything specific to this expression, right?
No, we are just returning references to it. Yeah, we can write tests with integers. We can try to do this with integers, and we have to see something like the permutations that were in the documentation.
I think that's it, right? It's not failing. No, it's not failing. Okay, so let's write a quick test for this.
Yes.
Let's write test fn test permutations. And what we want to do is basically let sequence equal vec of 1, 2, 3, 4, 5. And if we do let permutations, actually let's do let iter equal, what did we call it? X per combinator. I think we can just call it combinator at this point, or permutation.
Permutator by 2. Terrible name, but I like it. I like terrible names.
So permutator
seems like a metal band from the 90s. We are the permutators.
And we need to pass a reference to sequence. Okay, so now if we do let permutations, that's equal to iter. But this is going to be terrible. iter.iter.collect. No, it doesn't have to call it .iter. We can just call collect, right? And this is going to be back of iter2. No? Why doesn't like it? Cannot be built from an iterator of elements integer.
Because it returns references. It doesn't return.
Oh yes. So reference and reference. Point. And now we can check.
Try to debug permutations to see what's inside, and we check visually what's there. There is not the debug to print stuff.
Yes, so we can do print ln of.
There was not a debug macro to do this.
I think that's the same. Let's do dbg. Yeah, you convinced me. And the test. So okay, let's see what are we getting. We are never getting 0. So somebody commented that, and they were right.
But we don't have 0 in the vector.
Oh, that's correct.
We don't want 1 1, 2 2, 3 3, 4 4, and 5 5. They
let's
must
put
be
0. Let's do a simpler example, and now run it again. So we have the indices as well. The indices match the numbers. So we have 1 0, then 2 0, 3 0, then 0 1, 2 1, 3 1, 0 2. Is that correct? Why it goes to 0 2?
Yeah, we have 2 0.
Okay, so the first one is always increasing, and the second one.
Yeah, and the second one is the one slowly increasing.
And then we never have 3 3. We never have 2 2.
We never have 1 1.
We never have 1 0 0. So this is correct, right?
Yeah, this is correct.
Okay, so let me do a shitty test where I copy the result. Let expected equal.
But if you want to go and see the one in the documentation of permutations, they are fine. I mean, probably they are using 5, 6, and 7. It will be the same as us.
Cool. I only wish this wasn't formatted this way.
The auto formatter is not doing anything for you?
Oh.
Why?
Because it doesn't like me. Let's see what happens now. Nothing.
When you do this, I am amazed by your abilities with multi-cursor.
Oh, and when we have extra comma, is that going to be a problem?
Why?
We have no, it's not going to add an extra tuple item, but it just looks weird. This looks very weird. Okay, this is what I want, and give me a semicolon. Cool. So this is the expected. Now what we want to do is assert EQ permutation is equal to expected. Why it doesn't like it? Because everything is a reference.
Because your expected is not a reference to 0.
Permutation dot cloned.
Yeah, but the numbers inside the permutation are still
either dot cloned dot collect, I guess. Is that gonna work?
I don't know what.
Oh, copied. Okay, thank you in the chat. Either dot.
But now we have to change the type on the left.
And now the type, yes, you're right. But it still doesn't like that. Why? Oh yeah, we need to tell in that T needs to be copied to be able to call this one.
Oh God. No. Do a map.
And still you will have the same problem.
No, on except. No. Except equal to map that to the reference of numbers.
Can we just do sequence like this? Wait, let's see if I can do this shitty thing. Sequence 1. And then every 0.
What are you doing?
I am just creating references. That's what I'm doing.
Again, when you use multi-cursor, I'm carried away. You must do a channel when you do only this with some music in the background, like lo-fi or stuff like that.
We can do that. So permutations equal to expected. Still not happy. Why? Aren't this? This one takes ownership. We need to. Okay. I know. I think
you have it.
I think, and if somebody has marked a suggestion in the chat. Okay, cool. Is it gonna work? Yeah.
Okay, let's use this combinator with this permutator. Sorry, with our part 2. You want to do part 2?
Yeah, let's do another one. Let's do part 2. Whatever. Let's move all this stuff to the top because we could have created another file, but I'm lazy. So I'm gonna move everything to the top there, and then we'll refactor to a new file later. This tokenizer, why is it complaining? Because we have a to-do. But did we use it, right?
Yeah.
Okay, whatever. So now what we want to do is to create a new solution, which is going to be
part 2 permutator. And a new test, part 2 permutator test.
Let's write the solution first.
Yeah. test driven. Nope.
Why use the variable? Why don't you just use 0 and 1? Oh, I didn't know you could do that. I'm learning a lot. So you're basically saying that if I just do a reference to 1 and 0 and so on, is that just going to work? Because all the numbers are indexed the same way. So this is the same. Ooh, look at that. This is a great suggestion. Thank you. I like it a lot more. Yeah, thank you for that suggestion. Yeah, Google didn't understand it.
No, Google didn't understood this, but I understood, so we are fine.
Thank you, WGAF. That's awesome. This is why we do the streams, because we get people cool
to
like
learn.
you to teach us something. Yeah. Okay, so we were saying, sorry, I lost track. I got distracted with the
create
chat.
Another test with for the permutator, part 2 permutator test.
Sounds good. So we want to do test part 2 permutator. We also have benchmarks that we need to update, but we can do that in a second.
We can update them when this is working. The result must be the same.
This is now working because the code is the same, but we'll need to rewrite this test to use our permutator. Yeah. So basically what we want to do is we get all the expressions. Then we want to permutate over the expressions. So let permutator equal permutator new of expressions, if I can type. Okay, now what we can do is permutator. Now what we can do is to do a for.
Can't we do permutator map?
Actually, yeah, we can do permutator.map. Then we sum them, and then we do a max.
Yeah.
No, then we do the map is going to sum them and do the magnitude. Okay. So we have here left, right.
You have to put the round brackets because they will be a tuple. Yeah, left, right.
And now what we want to do is
magnitude of sum of reference to a sum, because we have to do reference to a sum.
Reference to a sum, of left and right.
To right. And the dot max at the end, or do we need to do dot iter dot max, or we can just go
dot max, I think.
Oh, and this is already our answer in theory.
In theory, yes. Let's see if it gets. It's not particularly happy. I'm sure there is some reference problem there.
What is complaining about?
Expected you type and it got an option.
Unwrap. Max can be.
Oh, yeah.
You have to unwrap the max.
If it's empty, there is no max.
Yeah.
Ooh, look at that. Let's see if it works. Part 2 permutator. Works. It's already 0.02 slower, apparently. But we can compare it with our benchmarks. So if we do
this, copy another line.
We need part 2 permutator and part 2 underscore permutator. And we need to call this part 2 permutator. So if we run the bench, CD year 2021, exercise 18, cargo bench.
And if you didn't did this in the last month, we have to wait. No, don't touch your keyboard now. Okay, part 2. Part 2. 46 milliseconds.
I expect that this one is going to be a little bit slower because we are doing a little bit of bookkeeping there, rather than the for loop is probably smarter at doing all of that, the nested for loops.
In the end, it's the same.
Yeah, there is probably a little bit of noise, but it was actually a little bit faster.
Yeah. There is a little bit of noise on your machine for sure, but they are with.
Okay, cool. Let's install itertools. Cargo add itertools. Apparently I did that before. So if we do the same solution, let's call it.
You want to do
part 2.
Okay, part 2 permutation.
Itertools.
Okay, fine. Itertools.
And we use itertools permutations, yeah. So we use permutator is basically itertools.
Look at the documentation now. Yeah, we have to give.
Why it doesn't give me?
Go in the help.
Okay, let's go in the documentation. Permutation, that's the function. How do you import it?
Because you
itertools. Okay, no, that's fine. I think that's what was missing, or not.
No, but you don't. It doesn't add permutation to your vector.
What does it do? So it takes self KU sides.
You see how it is used.
Oh, you're right. You're right. So it's basically just giving
it's
us
expression dot permutation 2. Try expressions.
But we need to import itertools to make that happen, I think.
Yeah.
So let's do that. Use itertools. Can we just use it here? I'm curious. I think so.
No idea.
Now we can just do expressions dot permutation. No?
Put that on the top. I don't know if that's what. Dot iter. Try to do dot iter before the permutation.
Dot iter. You're probably right. Dot permutations. Okay.
2.
What is 2? Oh, because this is the cardinality of the tuple.
2 elements.
Okay. Now let's see.
What gives to map is giving a tuple, separated elements. What is giving?
Somebody's suggesting filter by. Can you highlight that? I'm not sure I can. My chat is broken. When it comes to code, it breaks my chat. So whatever you do, good job.
No, at the moment it was the wrong. I don't have that message. It's normal.
Yeah, me neither. That's why I was asking you to do it.
A moment. Attendere, prego.
So expected as struct found tuple __. Okay, that's interesting. I'm not really sure I'm following why.
It wants me to highlight this message, the input lines,
exactly,
map, parse, permutation, filter, pi, map.
Yeah, pretty much. I'm going to copy paste it here. So input lines, map, well, we probably need this one. Then permutation 2, filter by. I'm not really sure this filter by, what does it do? Oh, yeah, because we need to remove. Permutation is not going to remove the same value.
Are you sure? Go in the documentation. There is no 5.5 if you look in the example output.
You're right. Okay.
Permutation, there are 2 types of permutation. Permutation and repeated permutations. We are not using a repeated permutation. We are just doing a permutation, so we don't have to filter. There will never be the same value twice.
Okay, so what we were doing was pretty much the same.
So right? Yeah, we just have to map.
We just have to map.
Our map, I don't know why, is wrong. Let's take a look why our map is... why parse again? We have to do the magnitude. The one that we have in line 230. Yeah.
So all of that should be the same, right?
Yeah.
Let's comment all of this. It's not happy here. What is expecting? Found the tuple __. Does permutation needs...
it gives you a vector, because permutation can give you a random amount of elements.
Okay.
That we know there will be 2 because we asked the permutation of 2. So you're getting a vector of references to vector to sum. So you're getting left and right in a vector of 2 elements.
Oh, okay, so can we destructure like this, I wonder? I have no idea if you can do that in Rust. Does it work? What's the actual error? Expected an array of slice. Found pattern match cannot match with input type. Interesting. Okay, so let's say items.
Yeah, items.
And then we just say item 0.
And items 1. That must be references to item 0 and item 1.
Oh, this is a reference. Okay. Should we just do this? Okay, so that's it.
Do you have the test for this?
No, we need to do it.
Okay.
That's 2 itertools.
Yeah, I'd say that we can't. There is a message that say that we can't destructor with the square brackets because the size is not no of the vector. The vector
makes sense.
20 elements.
So this one could technically panic if the size was 1 and we are trying to extrapolate the second one.
Yeah, but permutation 2, we know that we will have 2 elements because we put a 2 in permutations.
Okay, so what I was doing, this one, part 2 itertools. Let's see if it works first. It does work, and it's more or less the same time. Seems a little bit slower, but let's see with the benchmarks how much slower are we talking about.
Remember to import it in line 2.
And to use, actually. Cool, cargo bench again. If you want to be brave and make a bet in the chat which one is going to be faster, go for it.
The iter tool is giving a vector. I expect that is a little bit slower in creating the object itself.
Yeah, there is probably an extra allocation in the heap, right?
Obviously, is allocation of a quantity of memory that is reasonable, but
I agree. We know more the compiler in this case. Permutator is faster. Thank you for betting on our solution. Let's see.
Permutator. Still reminds me of some metal band from the 90s. So.
Could be an amazing name for between snail fishes and permutators. We can do a metal
The
concert.
permutator of snail fishes. What are you doing?
Okay, so let's
it's a little bit slower
so
because of
itertools was 53, permutator was 46, and it was the fastest, still being the faster even compared to part 2 where we did the manual for loop.
Yeah.
Interesting.
Cool.
Okay. I think we can commit all of this and wrap it up for
all
the
of
day.
this is very interesting.
So git status.
Obviously, we wrote way more code implementing the iterator ourselves, and this was a little bit tricky to think about it with permutator. With the permutation, we just wrote itertool permutations done. And you forgot an R in permutations.
Permutations.
And obviously, our permutator is fixed size of 2. Permutation is taking a number.
It's less generic.
Yeah, obviously it's less generic, so it's faster.
Okay, so I'm gonna switch to the wrapping up phase. And
okay,
I just want to quickly thank you the chat for all the amazing suggestions. So hopefully you're gonna stick with us next time. So I'll let Roberto do the finishing up.
Okay, let's wrap it up. You can find the recording on YouTube. The link is on the Twitch in the About section. If you are watching this on YouTube, we do live streaming on Twitch every Monday, 5 p.m. UTC. 5 p.m. UTC. Oh, yes, 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave comment in our PRs. The repository for this code is in this GitHub account. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the cleanest or more idiomatic one. If you know better ways, please let us know. Thank you to everybody for the suggestion, the collaboration, and everything. Are we going to raid somebody, Luciano?
We are.
We are. So thank you. See you next time.
Bye, everyone. And
bye.
The raid is going to start in a second. Bye, everyone.
Bye.